All right, problem number 9 for combined gas law. All right, so a gas held at a constant pressure. All right, so a constant pressure, we're going to put P1, and we're just going to put 1 ATM, 1 atmosphere. And we're going to go ahead and put P2 is equal to 1 ATM because it says that it's at a constant pressure. All right, has a volume 1 equals 3.5 liters. And so V2, not sure yet. Constant pressure has a volume of 3.5 liters at 300 Kelvin. Okay, so we have our temperature 1 is equal to 300 K. And it says if the temperature increases, so here's our T2 at 600 K, what is the new volume? So there we go. All right, so we know it's a combined gas law, so we're going to put P1 V1 all over T1 equals P2 V2 all over T2. Now, we only want this. So we are going to isolate this. V2 equals, let's just go ahead and put this side, P1 V1 all over T1. Okay, so all we did is write that. Now, we know that we would have to divide both sides by P2. And what if I plug in, let's say I put P2 there, they cancel out. So P2 is going to be divided because it cancels. All right, T2 is going to be multiplied by both sides, so it cancels. So it's going to be on top, so that's T2. All right, that is our manipulated formula now. We have what we want. So now let's just plug in the numbers. So I'm going to do that over here. Our P1, well, we know that was 1 atmosphere, times our V1, which was 3.5 liters, times T2, which was 600 Kelvin. All divided by, our pressure again is 1 atmosphere because it was a constant, and our initial temperature was 300 Kelvin. Okay, so let's go ahead, start canceling out. 1 atmosphere cancels, Kelvin cancels, and 300 goes into 600 twice. Put a 2 there, this becomes a 1. So we really have 3.5 times 2. Well, that's really super simple. Crunch in 3.5 times 2, and you should get 7.0, and our only unit left is liters. And that's how you do problem number 9.